Hello, everyone. Welcome. Let's get started. In this video, we are going to explore um, and connect to data in OneLake, the unified data foundation of Microsoft Fabric. So before getting started, I would like to just share my screen. And let me do it once again, just to be sure that everything is correct. Yes, I hope now everything is correct. So after sharing just my screen, actually it always takes some amount of time, so we're live. Okay, and now I hope we can just start once again. Hello everyone and welcome. In this video, as I mentioned a little bit earlier, we are going to just explore how to discover and connect to data in OneLake, the unified data foundation of Microsoft, you know, um, Fabric, right? So in many traditional analytics environments, data is spread across multiple storage accounts, databases, and file systems. Different teams often maintain their own copies of data, which can lead to duplication, inconsistencies, and challenges in finding the right information. As a result, analysts and data professionals often spend valuable time searching for data before they can begin transforming it, analyzing it, or building reports. Now, let's imagine that your organization has recently adopted Microsoft Fabric. Across the business, different teams have already started creating lakehouses, warehouses, and real time streaming solutions. However, as someone building new analytical solutions, you may not know what data assets already exist or where they are located. Before you can start delivering insights, you first need an efficient way to discover and connect to the data that others have already created. This is where OneLake becomes extremely valuable. OneLake provides a unified storage layer that brings together all Microsoft Fabric workloads into a single, centralized data environment. Instead of navigating multiple disconnected systems, you can use OneLake to easily discover, access, and collaborate on data across your organization. And in this video, we are going to learn how to use the OneLake Catalog to browse and locate existing data assets, create shortcuts that connect to data without duplicating it, and discover real-time data streams through the real-time hub. In the next slide, we'll begin by understanding what OneLake is and how it serves as the foundation for data storage and discovery across Microsoft Fabric. Okay, so now let's just take a closer look at OneLake and understand why it's such an important, component of Microsoft Fabric. OneLake serves as the foundation of the Microsoft Fabric Analytics platform, right? Of the Microsoft Fabric Analytics environment. Think of it as a single unified storage layer where all organizational data is stored and accessed. Rather than having data scattered across multiple storage systems, OneLake brings everything together into one centralized location. What makes OneLake especially valuable is that it changes the traditional approach to data storage and management. In the past, organizations often had to move or duplicate data between different platforms and services to support various analytics workloads. This is this not only increased storage, you know, um, costs, but also created challenges with maintaining consistent and up-to-date data. With OneLake, all Fabric experiences can work from the same data foundation. Whether you are using data engineering, data science, data warehousing, real-time analytics, or Power BI, you are accessing data from a shared storage layer. This reduces data silos, simplifies data management, and enables better collaboration across teams. Instead of spending time managing multiple storage accounts or creating duplicate datasets, you can focus on generating insights and building solutions using a single source of truth. In the next slide, we'll explore how OneLake operates at the tenant level and provides a unified data lake for the entire organization. Now, let's look at one of the most important characteristics of OneLake. It's a tenant-wide data lakehouse. When Microsoft is enabled for your organization, OneLake is automatically created and made available across the entire tenant, right? There is no need to provision separate storage accounts or perform additional configuration. It comes built in as part of the Fabric experience. OneLake provides a single centralized location for data across the organization. This means all Fabric workloads, whether they are used for data engineering, data warehousing, data science, real-time analytics, or reporting, can work with the same underlying data. A key benefit of this architecture is that it supports a single copy of your data. Instead of creating multiple copies for different teams, departments, or analytical tools, everyone accesses the same shared data stored in OneLake. In traditional analytics environment, data is often duplicated across systems to meet the needs of different workloads. Over time, these copies can become inconsistent, leading to confusion about which version is correct. They also increase storage requirements and management complexity. With OneLake, all workloads read from the same underlying files. When data is updated, those changes are immediately available to everyone who has access to that data. This creates a true single source of truth, helping organizations reduce data silos, improve consistency, and lower storage costs. In the next slide, we'll explore how to discover existing data assets across your organization using the OneLake Catalog. Now, let's just explore the different types of data that can be stored and managed within OneLake, right? So, OneLake is built around open data formats, ensuring that your data remains accessible and isn't locked into proprietary technologies. By default, OneLake uses Delta Lake for tables, which stores data in open Parquet files. This means that any tool capable of reading Delta Lake or Parquet data can work with your information, providing flexibility and interoperability across different analytics platforms. In addition to using open table formats, OneLake can store files in virtually any format, allowing organizations to manage a wide variety of data types within a single storage environment. The data stored in OneLake can take several forms. For example, it can include tables that are managed within lakehouses, warehouses, right? Sorry. And that's it. And also it can contain files such as Parquet, CSV, JSON, and many other formats commonly used for data storage and exchange. Another important data type is shortcuts. Rather than physically copying data into OneLake, Shortcuts allow you to create references to data stored elsewhere. This could be data located in Azure Data Lake Storage, Amazon S3, or even another OneLake location. From a user's perspective, the data appears as though it's part of the lakehouse, while the actual data remains in its original location. OneLake also supports semantic models, which provide the business-friendly data layer used by Power BI for reporting and analytics. Shortcuts are especially valuable in scenarios where source data is managed by another team or when organizational policies require data to remain in a specific storage location. Instead of creating duplicate copies, you can access and analyze the data directly through the shortcut, improving efficiency while maintaining governance requirements. In the next slide, we'll explore how data arrives in OneLake, right? And the different ways organizations bring data into their Microsoft Fabric environment. Pardon. Now that we have explored the types of data stored in OneLake, let's look at the different ways data can be brought into the platform. Microsoft Fabric provides several ingestion methods, allowing organizations to work with both batch and real-time data from a wide range of sources. The first method is mirroring. Mirroring continuously replicates data from external systems, such as SQL Server, Azure SQL Database, Azure Cosmos DB, and Snowflake. One of its biggest advantages is that data stays synchronized automatically. Whenever changes occur in the source system, those updates are reflected in OneLake, helping ensure that analytics workloads always work with current, just data. Another common approach is using pipelines. Built on Microsoft Fabric's data factory capabilities, pipelines enable organizations to orchestrate data movement and transformation processes. They can extract data from multiple sources, perform data preparation and transformation tasks, and then load the results into OneLake for further analysis. Organizations can also use data flows to ingest data. Data flows leverage the familiar Power Query experience, allowing users to connect to data sources, apply transformations, and load data into OneLake. This approach is particularly useful for users who have experience with Excel or Power BI, as it uses the same Power Query technology they may already know. For real-time scenarios, OneLake supports streaming through event streams. Um, Streaming enables continuous ingestion of data from sources such as IoT devices, application telemetry, sensor networks, and website clickstream events. This allows organizations to analyze and react to data as it's generated. Finally, there is direct upload, which provides a simple way to upload files directly into OneLake through the Fabric interface. And this option is useful for quickly bringing existing files into the platform without building a dedicated ingestion process. Together, these ingestion capabilities give organizations the flexibility to bring data into OneLake from virtually any source, whether it's historical data, continuously synchronized operational data, or real-time event streams. In the next slide, we'll explore how OneLake supports AI workflows and helps organizations build intelligent, data-driven solutions using Microsoft Fabric. Now let's explore how OneLake serves as the foundation, for AI experiences in Microsoft Fabric. AI capabilities within Fabric, including Copilot and Fabric IQ agents, rely heavily on their ability to find, understand, and interpret organizational data. OneLake makes this possible by providing a centralized storage layer and a unified catalog of data assets across the organization. For example, if you ask Copilot a question such as what were last quarter's sales trends, Copilot first needs to determine where the relevant data is located. To do that, it searches the OneLake catalog, identifying the datasets, tables, and assets that contain the information required to answer your question. In other words, the same catalog that helps user discover data also powers AI-driven experiences. By giving AI tools visibility into available data assets, OneLake enables more intelligent and context-aware responses. However, the quality of AI-generated insights depends heavily on the quality of your data organization. If data is scattered across multiple locations, poorly documented, or difficult to discover, AI assistants face the same challenges that human users do. That's why good data management practices are so important. When datasets have meaningful names, clear descriptions, accurate metadata, and well-defined relationships, Copilot can identify relevant information more effectively and provide more accurate results. Put simply, the more discoverable and well cataloged your data is, the more value you can get from AI powered features in Microsoft Fabric. A strong data foundation in OneLake doesn't just improve data access for people, it also helps AI work smarter and deliver better insights across the organization. In the next slide, we'll look at how to browse, discover, and connect to data in OneLake. So you can start using existing organizational data in your own Fabric solution. Let's now explore how to browse and connect to data in OneLake. Imagine you are working for a retail organization where data is distributed across multiple Fabric workspaces. The data engineering team manages cleansed and curated data in lakehouses. Business departments maintain warehouses containing key metrics and KPIs. And analysts have created semantic models for reporting and analysis. As you begin building your own analytical solution, you need to identify what data already exists and determine how to access it. Rather than recreating data assets or searching through numerous workspaces manually, you can use the OneLake catalog to discover and connect to the data you need. So the OneLake Catalog provides a centralized discovery experience for all data assets within your Microsoft Fabric tenant. It acts as a single place where users can search, browse, and learn about available data resources across the organization. You can search for items using their names, tags, or other attributes, making it easy to locate relevant assets even in large enterprises with thousands of data objects. One of the key advantages of the catalog is that it respects security permissions. Users only see assets they are authorized to discover or access. This permission-aware experience helps maintain data security while still enabling users to find resources available to them. As a result, different users may see different sets of data based on their roles and permissions. When you find a data item in the catalog, you can review important metadata before deciding whether to use it in your solution. These metadata includes details such as the item name, type, and owner, the last refresh time, the workspace where the item is located, applied sensitivity labels. Endorsement stats such as certified or promoted. These are the details that metadata includes. Having this information helps you quickly understand the purpose, quality, and reliability of a data asset before connecting to it. Organizations often use sensitivity labels to classify data according to its level of confidentiality and business importance. These labels help users identify sensitive information and make informed decisions about how data should be accessed, shared, and protected. They also support governance and compliance requirements across the organization. Another important feature is endorsement, which helps users identify trusted and approved content. There are three levels of endorsement. First one is promoted. That indicates that an item is ready to be shared and used by others. Any user with right permissions can promote an item to increase its visibility. Certified means that the item has been reviewed and meets the organization's quality and reliability standards. Certification can only be applied by authorized reviewers. Master data represents the highest level of trust for core business information, such as customer records, product catalogs, or reference data. This designation identifies an authoritative source of truth and can only be assigned by approved reviewers. It's important to note that most Fabric and Power BI items can be promoted or certified, while the master data designation applies specifically to data assets, such as lakehouses and semantic models. By using the OneLake Catalog to discover existing data assets, organizations reduce duplication, improve consistency, and encourage collaboration. Instead of creating new copies of data, teams can find, trust, and reuse data that's already available, helping everyone work more efficiently from a shared source of truth. In the next slide, we'll explore how to connect to discover data and start using it within your own Fabric Analytics solution. So once you have found the data you need in the OneLake catalog, the next step is connecting to it. A common way to do this is by using shortcuts. Shortcuts allow you to reference data stored in another workspace without copying or moving it. Because the data remains in its original location, any updates made by the source team are immediately available through their shortcut. This is especially useful for collaboration. For example, a data engineering team may manage clean transaction data in their lakehouse. Rather than creating another copy, you can create a shortcut to those tables in your own lakehouse and then apply business transformations, aggregations, and dimensional modeling to prepare the data for reporting and analytics. Shortcuts also support architectures such as the medallion architecture, where data progresses through raw, enriched, and curated layers without unnecessary duplication. Before creating a shortcut, it's a good practice to validate the data using the SQL Analytics Endpoint. Every lakehouse includes a read-only SQL endpoint that allows you to query tables using familiar SQL syntax. You can preview data, review schemas, and confirm that the dataset meets your requirements. Copilot can even help generate the SQL queries, making data exploration faster and easier. Creating a shortcut is simple. You can just open your Lakehouse, select New Shortcut, as you may see on the image on the screen, and choose OneLake as the source. Browse to the required workspace and Lakehouse, and select the tables or folders you want to reference. Thus, you create the shortcut. Once created, the shortcut behaves like any other table in your lakehouse and can be used in notebooks, SQL queries, data flows, and reporting solutions. Keep in mind that shortcuts may not be the best choice when you need a fixed historical snapshot, when latency affects performance, or when compliance rules require a physical separate copy of the data. Next, we'll explore how to work with semantic models in Microsoft Fabric. Okay, now, in addition to lakehouses and warehouses, the OneLake Catalog also helps you discover semantic models, which provide a business-friendly layer for reporting and analytics. Semantic models already contain predefined relationships, measures, calculations, and business metrics, making it much easier to build reports without having to model the data yourself. To evaluate a semantic model, simply open it from the OneLake catalog. The details page provides several useful views. The overview tab shows information such as the description, owner, refresh status, endorsement level, and sensitivity, just labels. The table section lets you uh, review tables and columns, and even preview sample data. The lineage tab helps you understand where the data comes from and what depends on it. The monitor tab displays refresh, history, and activity information. Once you have confirmed that the semantic model contains the data you need, Fabric provides several ways to start working with it through the Explore These Data menu. You can perform quick ad hoc analysis, automatically generate a report with key insights, create a blank report from scratch, use a report template, or build a paginated report for printing and distribution. If you prefer working in Excel, you can also select Analyze in Excel, which creates a live connection to the semantic model and allows you to explore the data using familiar pivot tables and Excel features. By reusing existing semantic models, you can accelerate report development, maintain consistency across the organization, and take advantage of trusted business metrics that have already been defined. In next slide, we'll explore how to discover and work with streaming data using the real-time hub. In the previous unit slide, we focused on discovering and connecting to batch data stored in lakehouses and warehouses. However, not all data arrives in batch. Many business scenarios generate data continuously, such as online transactions, inventory updates, application logs, and IoT sensor readings. To work with this type of data, Microsoft Fabric provides the real-time hub, a centralized experience for discovering and managing streaming data across your organization. While the OneLake Catalog helps you find stored data assets, the real-time hub specializes in data that's actively flowing through the organization. It allows you to discover event streams and real-time analytics resources that are currently generating and processing events. The center of real-time analytics are event streams. These are continuous flows of events coming from sources such as Azure Event Hubs, IoT devices, Apache Kafka, database change data capture systems, or custom applications. Each event represents something happening in real time, such as a product sale, a customer action, or a sensor reading. Streaming data is commonly stored in event houses, which contain one or more TQL databases. These databases are optimized for time series and event-based data and use Custo Query Language, or TQL. Support fast and efficient analysis. Because the data is automatically indexed as it arrives, organization can analyze large volumes of streaming data with minimal delay. Just as you use the OneLake Catalog to discover existing data assets, you can use the real-time hub to find streaming data sources created by other teams. This helps you reuse existing streams instead of building duplicate ingestion processes, saving both time and effort. In the next slide, we'll explore how to examine and interact with streaming data using the real-time hub. Now that we have discovered streaming data sources, let's see how to explore them using the real-time hub. To access the real-time hub, select real-time from the left navigation pane in Microsoft Fabric. As you may see from the screen from here. This opens the streaming data page, where you can view recently created event streams and SQL tables that you have permissions to access. Finding the right stream is just simple. You can browse by workspace, filter by source type, or source for a specific stream by name. When you select a stream, Fabric displays important details that help you understand and evaluate it, including the stream name and its source item, such as an event stream or KQL database, the owner and workspace where it's located, its endorsement status, any applied sensitivity labels. In addition to these metadata, the real-time hub provides activity information for each stream. You can see whether the stream is actively receiving events and when the data was last ingested. And this visibility helps you determine whether the stream is healthy, up to date, and suitable for use in production solutions. By reviewing both the metadata and activity details, you can quickly identify reliable streaming data sources and decide whether they meet your analytical requirements. In next slide, we'll look at how to use the streaming data sources you have discovered and incorporate them into your real-time analytics solution. Once you have discovered a streaming data source that contains valuable information, there are several ways you can work with it, depending on whether it's an event stream or a KQL table. For event streams, you can review stream properties and data profiles to better understand the incoming data. You can also use Fabric Activator to create alerts that automatically trigger actions when specific conditions occur, such as inventory dropping below a threshold or a sensor exceeding a critical value. If the event stream is delivering data into a Lakehouse, you can create shortcuts and incorporate that data into your existing analytics workflows. For KQL tables, you can perform real-time analysis by querying the data directly with query language. You can also build visualizations in real-time dashboards and configure alerts based on query results to monitor important business events as they happen. Another option is to create your own event stream from discovered data sources. So, which allows you to apply custom business rules, transformations, and routing logic without changing the original stream managed by another team. One of the most powerful capabilities in Fabric is the ability to combine streaming and batch analytics. Real-time data can flow from event streams into lakehouses where it becomes available alongside historical data. This enables you to create reports and analytics solutions that deliver both real-time insights and long-term trends in a single view. Next, we'll look at how to add new streaming data sources into Microsoft Fabric and make them available through the real-time hub. So far, we have seen how the real-time help us discover streaming data that already exists in Microsoft Fabric. But what if the data source unit isn't available yet? That's where the add data experience in the real-time hub comes in. It allows you to connect new external streaming sources and bring them into Fabric for real-time analytics. By selecting Add Data, you can access a variety of connectors, including Microsoft Source, right? Fabric events, Azure events, and external sources. Microsoft sources, these are like Azure Event Hubs, Azure IoT Hub, and Database Change Data Capture, or CDC feeds. Fabric events, these are including workspace changes and OneLake file operations. Azure events, uh, these are Azure Blob Storage events. And external sources include Apache, Kafka, Amazon Kinesis, and Google Cloud Pub or SAP. And these connectors make it possible to ingest streaming data from a wide range of cloud services, business applications, and event-driven systems. Whether you are monitoring IoT devices, processing application events, tracking business transactions, or integrating cloud-based event streams, the add data experience provides a simple way to bring those real-time sources into Microsoft Fabric. By combining discovery capabilities with broad connectivity options, the real-time hub becomes a central location for managing both existing and new streaming data across your organization. Next, we'll move to a hands-on exercise where you discover and connect to data in OneLake. So we'll create a lakehouse with sample sales data, find it through the OneLake Catalog, create shortcuts for cross-workspace access, query data using the SQL Analytics Endpoint, and explore semantic just models. Okay. Pardon. Let me give a little bit info about the lab that I'm going to demonstrate. In this lab, we'll work through an end-to-end scenario that demonstrates how to discover and connect to data in OneLake using Microsoft Fabric. Throughout these lab exercises, we'll learn how to locate data assets, connect to them efficiently, and explore different ways to consume and analyze data across the Fabric ecosystem. So what we're going to do, we're going to create a workspace, create a lakehouse, and load sample data. We're going to load data into a table, and we're going to browse the OneLake catalog to discover data, explore Lakehouse tables and schema, and create a shortcut to access data from another workspace. Also, we're going to query data using the SQL Analytics Endpoint, create and explore a semantic model, and optionally, we can use Copilot to help generate a SQL query. And by the end of this exercise, we'll have practical experience using the OneLake Catalog, working with shortcuts, querying data through SQL Analytics endpoints, and leveraging semantic models to accelerate analytics and reporting. Okay, now I'm going to move my web browser where I have already opened my Fabric platform using my email address. And if we go to workspaces, there is roughly, except that one, there is no workspace. Now let's apply whatever we described in our previous slide. So first we're going to create a workspace. And I'm going to create a workspace. So from workspace, I say new workspace. And by the way, I have to be sure that I have selected this one, Fabric, and let's say workspace and new workspace. And I'm going to call it OneLake Lab. And as a description, I'm going to say lab propose only. And here I'm going to select my fabric trial. And then I say apply. Thus, I'm creating my workspace. Now I'm inside of my workspace. The next step is creating a lakehouse and loading sample data. So I'm going to also just share the link where you can find, uh, I mean, you can find the link to sample data set, right? And I'm going to open one more web browser. Here I'm saying Control V, and this is my sales JSON file. Right click, or yes, right click and save as. And I'm going to save this JSON file on my desktop. Actually, I have done it. So let's save once again. And I can simply, close that web browser. Then while I'm in my inside of my workspace, from new item, I'm saying Lakehouse. If I don't see it here, just I simply type here Lakehouse, right? And then I'm selecting this one. Then I'm going to give a name like OneLake, Lakehouse, and create. Thus I'm creating my Lakehouse. As soon as I'm creating my Lakehouse, on this Explorer pane, I'm seeing my tables and files. Tables automatically creates DBO schema, and there is nothing under files. And here also I successfully create a SQL Analytics endpoint. Now I'm going to upload the downloaded CSV file into my files folder. From here, ellipsis, I'm saying upload files. Once again, upload files. And I'm going to click on browse button, and from desktop, I'm going to selecting my CSV file, and I say upload. Now my CSV file has been already uploaded into files. If I click on here, I can see that file is already uploaded. And just for querying my file, I need to load this file into the table. Right away, from here, if I select table view, I can see, these files. I mean, my file in this format. So let me change it to file view. And from here, just to load my sales CSV file into the table, I'm going to click on this. And from this ellipsis, I'm saying load to tables and say new table. Okay. Now, what I'm just going to do, I'm going to, keep, all the stuff as they are looking like on the screen. So say load, and thus I'm going to load my JSON file into the table. The next step will be just browsing the OneLake Catalog just to discover data. And let's wait for a while. Okay. Yes. Okay. Now we successfully created sales table. So from OneLake Catalog, if I say OneLake Catalog, here I can see all the stuff that I have, in my workspace. These walls, before creating my OneLake Lakehouse, if I click on this, for example, I can see this kind of information. Location, data updated, owner, and SQL connection string, right? And I can, see all this information that is directly related to my table. Okay. Now, what we are going to do, so let's also just click on this here. Um, so we are going to explore Lakehouse now. So for this purpose, I'm going to back to my Lakehouse. This is my OneLake lab. And here I can see my OneLake. So let's click on this. And this is my file. And from tables under DBO, I can see my sales. And I'm going to click on this. Thus, I see this, view. And if I change it to file view, here I can see, other stuff, right? Like data log. Let me expand it. Parquet extended name, file name, and metadata. So this table, it means that is stored as Parquet files in the Delta Lake format. And the Delta log subfolder contains transaction logs that track all changes to the table, enabling features like ACID, transactions, and time travel. Now I'm going to create a shortcut to access data from another workspace. So let's go to Workspace. And from here, actually, let's select this OneLake Lab workspace. I'm here in this workspace. So what I'm just going to do, I'm going to create one more just Lakehouse. So say new item and Lakehouse. And this time I'm going to give analytics name to my new Lakehouse. And this is my second Lakehouse in my workspace, right? And there is nothing if I select table or files, there is nothing. So what I'm just going to do, I'm going to create a shortcut to the Lakehouse, so-called OneLake, Lakehouse, where we have already uploaded our sales CSV file. So for this purpose, while I'm here on ellipsis, I'm saying new shortcut. And the new shortcut is going to be created. So here, I say Microsoft OneLake, and this is OneLake Catalog, where I can see all the stuff that I have created. So from OneLake Lakehouse, I know that my data is located here. I say next, and then I'm going to say connect. Okay, and here, let's select all files and tables under DBO. We see, sales table. And I can say next. And thus I'm seeing my, file or table in another lakehouse to which I'm going to create a shortcut. And I say create. Thus, my shortcut is going to be created, right? And so this is my analytics lakehouse under DBO. Okay, let's say if I don't see anything here, I can refresh all. And under files, I see my, sales file. So just to query my data, what I'm just going to do from here, I say upload to tables, new table, and it's going to be uploaded to tables. And I say Parquet and say load. And it's going to be loaded here into the tables. And let's wait for a while. And I successfully create sales table under here. So what I'm just going to do now, it's time to query my data using SQL Analytics, endpoint. So from here, I'm changing it into SQL Analytics endpoint. So now what I can do, I can use this SQL query pane just to query my data. For example, let's say new SQL query. Sorry, let's keep this one. And I'm going to type this one that is select item, sum quantity times by unit price. And this is going to be displayed as a total revenue. And then quantity as total quantity from sales table. And I'm going to group them by item and order by total revenue in descending order and say run. And thus the query is going to be run. So this is what I'm just going to, get, right? Okay. So let's write our second query. So new SQL query, and I'm going to copy paste. And from here, I'm going to display 5 customer name based on the quantity that, they have bought. And it's going to be grouped by customer name. All values are coming from sales table. And it's going to be ordered by total revenue in descending order. And say run. And I'm going to get this top customers list, right? Okay. Now it's time to create and explore the semantic model. So, so let's go to our OneLake Catalog. We're going to OneLake Catalog, or actually, let's go to our workspaces, OneLake Workspaces. Here I have two lakehouses. The second one is Analytics. So here, what we can do, we can say new semantic model. We're going to create and explore new semantic model. And from here, so we have to complete some stuff, like, for example, selecting the workspace. This is the workspace that we are in. And also, let's give a semantic model name like Analytics. And then what we can do, we can just select all this one and say confirm. Thus, semantic model is going to be, created. And then let's see, yeah, it's going to be created. And then after creation, we can explore our, semantic just model, right? And this is, everything is happening in OneLake, right? So this is my analytics. Actually, it would be better to change the name because we have two analytics. One is for Lakehouse, another one is for semantic model. So yeah, this is our, semantic just model, right? So yes, this is what we are getting. So okay, so let's go back to our OneLake house, or just let's say to Workspace. Let's select this Workspace. And here under the Analytics Lakehouse, we have Semantic Model, Analytics Semantic Model. If we click on here, we can say explore this data, and thus we get this window, right? We get this window. So what we can do, for example, we can drag items to, let's say, for example, matrix, right? So let's drag, and these are our, yeah, collapse. These are our items. And then, for example, we can drag and drop quantity. So let's do it. And thus we get this kind of matrix, right? And from visualization, so let's say, let's expand. From visualization uh, pane, we can select, for example, a column chart, or let's say bar chart. Let's say column chart, cluster column chart. Okay. And then we can, or it's better actually to select this one, cluster bar chart. And then we can say drag and drop our item. And let's say, okay, item by item for 2 times, actually, which is not good. Okay. And now I'm just going to item and then quantity. Thus, I'm getting, this, visual. It means that thanking to semantic model, I can explore this semantic model and can get this kind of outputs, right? Okay. So let me go back to our slide. And also, yes, I hope, I'm sorry, I'm just going to display the last, um, I'm going to display the, yes, at last I got this one. Okay, so that brings us to the end of this session. Discover and connect to data in OneLake. Today, we explored how OneLake provides a unified data foundation for Microsoft Fabric and how to discover data through the OneLake Catalog, connect to data using shortcuts, work with semantic models, and discover both batch and streaming data sources across the organization. Actually, I gave the necessary theoretical information about this, but I didn't demonstrate how to do this. I hope in next labs we'll have this opportunity. And also, I hope this session has helped you better understand how OneLake simplifies data discovery, improves collaboration, and enables analytics teams to work from a single source of truth. Thank you very much for watching, and I appreciate you taking your time to join me in this learning journey. In our next session, taking place on Saturday, August 8th, 2026, we'll be covering creating Microsoft Fabric Lakehouse, and we'll dive deeper into building and managing lakehouses, loading data, and using them as the foundation for analytical solutions in Microsoft Fabric. I look forward to seeing you there. Until then, stay curious, keep learning, and have a great day. Thank you. Yok.